All right, so get this. There are like trillions of planets out there,
Trillions.
but we haven't found like a single shred of evidence of life out there beyond Earth.
Yeah.
Kind of crazy, right? It's a real head scratcher.
It really is. And that's the heart of what we call the Fermi Paradox, right?
Yeah.
This really baffling conflict between a very high probability that there is alien life out there
Right.
and the just deafening silence that we've encountered so far.
Yeah.
Your stack of sources today really dives deep into this, and we're going to unpack it all.
Okay, so the universe is massive. We get it.
Right.
But to really like grasp this paradox, shouldn't we start with just understanding like how likely is it that there's life out there, extraterrestrial life?
Absolutely. Yeah.
Right.
I mean, think about this. Just in our galaxy alone,
Okay.
there are billions of stars.
Right.
And studies suggest that most stars have planets orbiting them.
Oh, wow.
So that means there are potentially trillions of planets in our galaxy alone.
Okay, so there's a lot of planets, but just because there's a ton of planets doesn't automatically mean they're teeming with, little green men.
Right, exactly. And that's where this this idea called the Drake equation comes in.
Okay.
Which was an attempt to actually calculate the number of civilizations in our galaxy that could communicate with us.
Okay.
Now, this equation has a lot of variables and a lot of assumptions baked into it.
Yeah.
But even if we use the most conservative estimates,
Right.
the numbers are still pretty astounding.
Okay, so even if we're playing it super safe, the math suggests there should be other civilizations out there.
Yeah, exactly.
Okay.
Now, I think one of the most debated factors in this whole equation is the fraction of planets that could actually support life.
Right.
But, recent discoveries are really changing the game here.
Okay.
For example, the discovery of things called extremophiles.
Extremophiles.
Organisms that can thrive in these really extreme environments, like here on Earth.
Yeah.
That suggests that life might be far more adaptable
Okay.
and resilient than we previously thought.
So those weird bacteria living in like volcanic vents or at the bottom of the ocean,
Exactly.
they're telling us that life could exist in all sorts of crazy places we haven't even considered.
Exactly. Precisely.
Okay.
Which brings us to the kind of the heart of this whole paradox, right?
Yeah.
If life could be so prevalent, why haven't we found any evidence of it yet?
All right. So we've got a universe full of planets, a decent chance that at least some of them harbor life, and yet crickets. So, like, what gives? So let's dig into some of the explanations, starting with the rare Earth hypothesis.
Yeah, so the rare Earth hypothesis basically suggests that, while planets might be common, planets like Earth with that perfect mix of conditions for complex life, are incredibly rare.
Right.
Like we might be a cosmic fluke, a 1 in a trillion kind of deal.
So we're basically winning the cosmic lottery by being here.
Yeah, I guess you could say that.
That's both flattering and a little terrifying.
Yeah, definitely.
So what are some of the specific factors that make Earth so special?
So a lot of people point to our position in what we call the Goldilocks zone, right?
Yeah.
Around a stable star, not too hot, not too cold.
Right.
Just right for liquid water.
Yeah.
Then there's our protective magnetic field, right? That shields us from all that harmful solar radiation.
Right.
And we can't forget about our unusually large moon, right? Which stabilizes our planet's tilt, creates a more stable climate.
Okay, I see the point, but is it possible, we're being a bit anthropocentric here, like maybe life doesn't need all of those specific conditions? What if there are forms of life out there that don't need liquid water?
Yeah.
Or even oxygen?
That's a fair point. And that's exactly why the rare Earth hypothesis is so debated, right?
Right.
It's possible that we're underestimating life's ability to adapt and thrive in environments that we would consider, totally hostile.
Right.
But even if life can exist under, a wider range of conditions, maybe that leap from simple organisms to intelligent, communicative civilizations like us.
Right.
Maybe that's the real hurdle.
All right, so maybe intelligence is the real bottleneck here. And this brings us to another contender, the great filter theory, right?
Right, exactly. And this one argues that somewhere along the path from simple life to a spacefaring civilization, there's a massive obstacle, a filter, that very, very few species manage to pass through.
So it's like an evolutionary game of red light, green light. Most get stopped along the way.
Exactly.
And the unsettling part is we don't know where this filter lies.
Right. We have no idea.
It could be behind us, meaning the emergence of life itself is incredibly rare.
It's the hard part.
Or
it's ahead of us, meaning that maybe civilizations reach a certain level of advancement, and then, boom, something wipes them out.
Okay, now I'm starting to sweat a little bit. This great filter idea, it puts a whole new spin on our search for extraterrestrial life.
It does, right.
Yeah.
It kind of transforms the search from a quest for connection into like a race against time.
Right.
To figure out how to avoid this potential filter.
So maybe we're not just trying to find aliens, we're trying to figure out how to survive.
Yeah.
That's a whole lot of pressure.
Yeah, it really is. But on a more, I guess you could say a more hopeful note, maybe our very awareness of this potential filter might be our saving grace, right?
Right.
By studying the Fermi Paradox and understanding these potential pitfalls, maybe, just maybe, we can learn how to avoid the same fate.
So maybe the answer to the Fermi Paradox isn't out there in the stars, but here on Earth, within ourselves.
Perhaps, yeah.
Okay, that's some seriously profound stuff, but it's not all doom and gloom, is it?
No, not at all.
We're actively searching for life out there.
Absolutely.
And we're developing some incredible tools to do it.
Some really mind-blowing stuff.
Okay, so less existential dread and more cosmic adventure.
I like it.
I like the sound of that, so let's dive into some of those efforts, starting with the James Webb Space Telescope.
Okay, so the James Webb Telescope, that is a game changer.
Oh.
It's allowing us to analyze the atmospheres of distant planets.
Okay.
For specific biosignatures.
Okay.
Telltale signs of life.
So rather than just spotting a dot in the sky, we can actually get a sense of what's happening on the surface of these distant worlds.
Exactly. For example, we can look for the presence of oxygen.
Yeah.
Methane, water vapor, all indicators of potential biological activity.
Right.
Imagine detecting a significant amount of oxygen in the atmosphere of a planet light years away.
Yeah.
That'd be a pretty compelling clue, wouldn't it?
Oh, absolutely. Front page news for sure. But what about those planets that might harbor life as we don't know it?
Yeah.
Like the extremophiles we talked about?
Right. How do we even begin to look for that?
Yeah.
It's a great question.
Yeah.
And it's one that scientists are really wrestling with right now. We're developing new techniques and instruments that can detect a wider range of biosignatures.
Okay.
Ones that might not be associated with life as we know it.
So we're expanding our search beyond our own limited perspective on what life might look like.
Exactly.
That's fascinating. But even with these incredible telescopes, the universe is just so vast.
It's incredibly vast.
Are we really limited to just looking? Shouldn't we be doing more to reach out?
Well, that's the thinking behind the Breakthrough Starshot project.
Okay.
Imagine a fleet of tiny, light-powered spacecraft traveling at a significant fraction of the speed of light.
Okay.
Sent on a mission to our nearest star system.
Wait, are we talking about sending actual spacecraft to another star system?
Yeah.
That sounds like something straight out of science fiction.
It does, doesn't it?
Yeah.
But the technology behind it is grounded in real science.
Okay.
And many brilliant minds are working to make it a reality.
Wow.
I mean, think about it. If we could send probes to another star system, even if it takes decades, the potential for discovery would be mind-boggling.
Okay. I'm definitely getting some Star Trek vibes here.
Sure.
But I have to ask, even if we could get these probes to Alpha Centauri, what are the chances of them actually finding anything?
Well, that's the million-dollar question, isn't it?
Yeah.
We just don't know for sure what awaits us in that star system.
Right.
But even if we don't find definitive proof of life, the data these probes could gather about planets, stars, interstellar space would be invaluable.
Okay, so it's not just about finding aliens, it's about expanding our knowledge of the universe and pushing the boundaries of human exploration.
Absolutely.
Right.
And let's not forget the incredible role that AI is playing in this whole search.
Right. AI, right.
AI is helping us analyze these massive data sets, identify patterns, and search for signals that we just might otherwise miss.
Right. It's like our cosmic detective sifting through mountains of data to uncover these clues that our human minds might not even be able to grasp.
Exactly. And who knows, maybe the first to detect an alien signal won't be a human astronomer peering through a telescope.
Right.
But an AI algorithm crunching numbers and spotting anomalies in this vast sea of cosmic data.
Now, that's a fascinating thought. We're using the power of AI to search for other intelligence. It's like a cosmic feedback loop, isn't it?
It is, and it speaks to, I think, the ingenuity and adaptability of human beings, right?
Yeah.
We're not just waiting for the universe to reveal its secrets.
Right.
We're actively developing new tools and strategies to uncover them.
So even though the Fermi Paradox highlights the vastness and silence of the universe, it also highlights our determination to find our place in it.
It does, and that brings us back to the central question, right?
Yeah.
Despite all our efforts,
Yeah.
why haven't we found any concrete evidence of alien life yet?
Right.
Is it simply a matter of time? Or is there something else at play?
And with that, I think it's time to take a quick break and delve into some of the more mind-bending possibilities.
Ooh, stay tuned, because we're just getting started.
Okay.
The Fermi Paradox has more twists and turns than a cosmic roller coaster.
All right, I'm buckled in.
Let's shift gears for a second here.
Okay.
What if the Fermi Paradox isn't really a paradox at all?
Okay.
Like maybe we're making this whole thing more complicated than it needs to be.
Wait, are you saying there's a simple explanation we're all missing? Like what?
Well, the universe is, I mean, it's mind-bogglingly huge, right?
Yeah, we've established that.
We've talked about that. Maybe those alien civilizations are out there.
Yeah.
But they're just too far away for us to detect.
So it's not that they're ignoring us. It's more like we're trying to have a conversation with someone across like a vast canyon.
Right.
Our signals just can't reach them.
Exactly. I mean,
theirs can't reach us.
Even if a civilization sent out a powerful signal, thousands of years ago,
yeah,
it might not have reached us yet.
Right.
And any signals we've sent out haven't traveled very far in the grand scheme of things.
Okay, that makes sense. But let's say there are civilizations relatively close to us, close enough for signals to have traveled back and forth.
Right.
What if they're deliberately choosing to remain silent?
That's a pretty intriguing possibility, right?
Yeah.
It's actually a theory known as the zoo hypothesis.
Okay.
Imagine a super advanced civilization observing us from afar, like scientists studying a primitive culture.
Right.
They might be choosing to stay hidden, allowing us to develop naturally without interference.
Hold on. If they're that advanced, wouldn't we have noticed something? Some kind of evidence of their existence, even if they're trying to stay hidden?
Not necessarily. What if their technology is so advanced that it's completely undetectable to us?
Right.
I mean, imagine them using forms of energy or communication that we haven't even dreamed of yet.
Yeah.
It'd be like, trying to hear a dog whistle.
Yeah.
The sound is there, but we simply lack the ability to perceive it.
Okay, now that is a genuinely unsettling thought. We could be surrounded by alien civilizations, and they're just watching us like we watch ants in an ant farm.
It definitely makes you question, our assumptions about what we can observe and understand, doesn't it?
Big time. It's like the Fermi Paradox is forcing us to confront the limits of our own perception.
Yeah.
We're looking for what we think we should find.
Right.
But what if we're looking in the wrong way or for the wrong things entirely?
Exactly. And that's what makes this whole thing so fascinating.
Right.
It's not just about finding aliens. It's about pushing the boundaries of our understanding of the universe. And as we've been discussing, ourselves.
So even if we never find definitive proof of extraterrestrial life, the search itself is transforming our understanding of what's possible.
Absolutely. And maybe that's the point of the Fermi Paradox, right?
Okay.
It's not a puzzle to be solved, but a catalyst for pushing humanity forward.
Okay, I can get behind that. But all this talk about the Fermi Paradox and its implications, it's a lot to process.
It is. It's a lot to unpack.
What does it all mean for us, for humanity?
That's the question that lingers, isn't it?
Yep.
I mean, it's one thing to discuss theories and possibilities, but it's another to grapple with the very real impact this paradox has on our understanding of ourselves, our place in the universe.
All right, let's get philosophical.
All right, let's do it.
What, deep cosmic insights does the Fermi Paradox offer about humanity?
Well, for starters, it forces us to confront, our assumptions, right? We tend to project our own experiences and limitations onto the universe.
Right.
We imagine aliens building spaceships like ours, communicating in ways we understand.
Yeah.
But what if those are just tiny boxes we're trapping ourselves in, right?
So you're saying the Fermi Paradox is like a cosmic wake-up call, reminding us that we need to think bigger, bolder, and beyond our limited perspective.
Exactly. It challenges us to imagine life and intelligence that might be radically different from anything we can currently conceive of.
Yeah.
Life as we don't know it.
Right.
And that in itself is a powerful and humbling exercise.
I like that. It's like the paradox is this giant mirror reflecting not only the vastness of the universe, but also the limitations of our current understanding.
It's a reminder that we're still at the very beginning of our journey of cosmic exploration.
Yeah.
And that the greatest discoveries might lie in the realms we haven't even begun to imagine. But the paradox also highlights something else.
Okay.
Our deep-seated desire to connect.
Right.
To know if we're alone in this vast universe.
You're right. There's something inherently thrilling about the possibility of discovering another intelligent species out there.
Yeah.
Even if it's a little scary, it would redefine everything.
Absolutely. It would change our understanding of our place in the cosmos, challenge our beliefs, and force us to confront questions we may not be ready to answer.
Right.
But even if that definitive proof never comes,
Yeah.
the very act of searching pushes us forward.
Right.
It fuels scientific advancement, technological innovation, and even philosophical inquiry.
It's like the Fermi Paradox is this engine of curiosity, driving us to explore, to invent, to push the boundaries of what we know and what we think we know.
Exactly. And who knows, maybe the most profound discovery isn't out there among the stars.
Yeah.
But within ourselves, the realization that our capacity for wonder, for exploration, for understanding is as vast as the universe itself.
Wow. Okay, that's a beautiful way to put it.
Thank you.
The search for alien life is, in a way, a reflection of our own inner drive to explore and understand.
It is.
Even if we never find aliens, the journey itself is transforming us.
And that, I believe, is the most profound lesson of the Fermi Paradox.
Okay.
It's not just about finding E.T.
Yeah.
It's about discovering who we are.
It all circles back to us, huh?
It does.
So even though this whole deep dive started with a mind-boggling question, where is everybody?
Yeah.
It ultimately leads us back to ourselves.
Indeed. And perhaps that is the greatest paradox of all.
We've covered a lot of ground here.
We have.
We've explored the vastness of space, the mind-bending theories, and the ongoing search for signs of life beyond Earth. We've even touched on the profound implications of the Fermi Paradox and how it's shaping our understanding of humanity's place in the universe.
Yeah, it's a lot to think about.
Yeah.
And yet, the Fermi Paradox remains. We're still left with that question.
Yeah.
Where is everybody?
Maybe that's the point.
Maybe.
Maybe the real value of the Fermi Paradox isn't in finding a definitive answer, but in the journey itself. It's about the questions it raises.
Yeah.
And the discoveries it inspires, both about the universe and about ourselves.
I couldn't agree more. The search for extraterrestrial life is a journey of exploration.
Yeah.
Both outward into the cosmos and inward into ourselves.
And on that note, I think it's time to wrap things up.
Let's do it.
Okay, so we've done it. We've gone through it all. The vastness of space, the mind-boggling theories, But what does it mean? Like, what does the Fermi Paradox tell us about us? You know, humanity.
That's the question, isn't it? I mean, even if we never actually, shake hands with an extraterrestrial, wrestling with this paradox, it really has these profound implications.
I'm ready. Lay them on me.
All right. Well, it forces us to look inward.
Okay.
The Fermi Paradox isn't just about what's out there.
Right.
It's also about what's in here.
Yeah.
It's about our assumptions, our biases.
Okay.
Our hopes and our fears.
So you're saying the search for alien life is also like a search for self-understanding.
Exactly. Yeah. And take the way we picture aliens, for example. We tend to imagine them as these humanoid, technologically advanced beings.
Right, with spaceships.
Yeah, exactly.
Yeah.
But who's to say that's the only way intelligence can manifest?
Right.
The Fermi Paradox, I think it really challenges us to expand our definition of life and intelligence beyond just, our limited human perspective.
So we need to, break free from our Earth-centric thinking.
Exactly. Yeah. And maybe the reason we haven't found aliens is that we're looking for the wrong things.
Okay.
And the wrong places. What if intelligence out there is so different from our own that we wouldn't even recognize it?
Okay. Now that's a humbling thought.
It is.
We could be missing the signals because we're not even tuned to the right,
Frequency, yeah.
Frequency, yeah.
Yeah, like we're searching for a radio station, but we're on the wrong band.
Exactly, yeah.
And I think that's the beauty of the Fermi Paradox.
Yeah.
It forces us to question everything we think we know about life, intelligence, the universe itself. But, it also speaks to something else, too.
What's that?
Our really deep-seated need to connect.
Right.
To find out if we're alone in this vast,
Cosmic ocean, yeah.
Cosmic ocean, yeah.
And that yearning for connection, I mean, it's a really powerful motivator.
It is.
It's what drives us to explore, to invent, to reach out into the unknown.
And that's why I think the search for extraterrestrial life is it's so much more than just a scientific endeavor, right? It's a reflection of our humanity, of our need to understand our place in this grand scheme of things.
So even if we never find, like, definitive proof of alien life,
Yeah,
the journey itself is profoundly meaningful.
it is.
It's shaping how we understand ourselves, the universe, the nature of existence.
Absolutely. I couldn't agree more. And it forces us to grapple with some pretty big questions.
Like what?
What is the meaning of life?
Oh, wow.
What is our purpose in this vast universe? Are we alone? And if so, what does that mean for our future?
Yeah, those are some heavy questions.
Yeah, they are.
Yeah.
But, facing those questions, even without having clear answers,
Right.
can be incredibly powerful. It can help us, appreciate the fragility and the preciousness of life here on Earth. And it can inspire us to create a better future for ourselves and for generations to come.
I like that.
Yeah.
So maybe the ultimate answer to the Fermi Paradox isn't out there among the stars, but right here within ourselves.
Right. Maybe the most profound discovery is the realization that our capacity for wonder, for exploration, for understanding, it's as boundless as the universe itself.
That's a beautiful way to put it.
Thank you.
So the search for extraterrestrial life is, in a way, a search for our own potential.
It is, and as we wrap up this deep dive, I want to leave you with this thought.
Okay.
Even if we never solve the Fermi Paradox,
Right.
the questions it raises, the possibilities that it inspires, the journey of exploration it sets us on, are all testaments to the boundless potential of the human spirit.
So keep looking up, keep asking questions, and never lose that sense of wonder.
I love.
Who knows what incredible discoveries await us in this vast, enigmatic universe we call home.
Well said.